继续 Braid 时空幻境的周年重制版，上一期 Full Game Speedrun 打了一次，45分22，差的不多。前半还算可以，后半有两关发生了很大的失误，那两关嘛也没刻意去练过，所以都不知道会有这种事情。下一次的话，等这个 Programming 加 Playthrough 全部看完了，可以再来一次。那次我估计应该就能搞定了。Sound Music 跟 Visual 还得慢慢打。来 ，Programming 不知道多长。This area directs you toward commentaries related to programming. Many, but not all, of these are available via other routes through the commentary, but they are gathered here for convenience. 好像并不是很长，是吧？啊，上来就是这个，上来就是这个啊，后面带呢，哎呀呀呀呀呀呀呀呀，马吉克，啊，后面带的设计，大家看着。An equation that helps make word 4 go 啊，就那个 equation 啊，这个我就不乱串了，因为基本上在别的地方应该都看过了。Cloud Design 是在对 Infinite Series 对的。Right.
Programming would present advocated form until order some steps.
Geometric Series 那个
It's representable in closed form very simply. We just need to do an extra add, a multiply, and a divide. Much cheaper than running many simulation steps.
Simulation steps.
We'll cover the exact math for this in the next part.
这个 John 本来就是个 programmer。The mathematics behind the clouds on Word 4，这没看过吗？在哪儿啊？在这儿。
I wanted World 4 to have a feel that matches the rest of the game in basic situations. You run around and jump and climb at the same speed as in other worlds.
Shit.
Then we use your motion to drive the advancement of time for everything else in the level. So first, we run our simulation step for only the player, holding the rest of the world constant.
Oh.
This gives to drive the advancement of time for everything else in the level. So first, we run our simulation step for only the player, holding the rest of the world constant. This gives us a value, delta x0, the amount by which the player moves in the x direction if the rest of the world were totally still. Most of the time, it's very simple from there. If we want to know how much time should pass for the rest of the world, we just take delta x0 and multiply it by some factor f that we use to determine how much time passes for each unit moved in space. This constant is arbitrary. We can turn it up or down, and time will move faster or slower relative to your own motion. We'll call the amount of time that passes as a result of this conversion delta t0. Delta t0 is just delta x0 times f. Now we're concerned with a special case. What if the player is standing on something that's moving? As we mentioned, the movement of whatever he's standing on should carry him as time passes, affecting the total x distance that he moves. So the amount of time that passes with each step should be different. Once we have computed delta t0, we know how far the platform or cloud would have moved in that time. If v is the velocity of the cloud, it will move by v times delta t0. Because that cloud is carrying the player, this also represents the additional distance the player will move. So if we say that delta x1 equals v times delta t0, the total distance the player will now move is delta x0 plus delta x1. But this extra distance moved by the player means that more time should pass. If we say that delta t1 is this additional time, so that the total time passing so far is delta t0 plus delta t1, then just like before, we use f to convert space to time. Delta t1 is equal to delta x1 times f. But so far we've only simulated the platform for a delta t0 amount of time, so we need to add extra time, which means adding extra distance, which means adding even more time. So we can compute delta x2, delta t2, delta x3, delta t3, and so on. Each delta x is just v times the previous delta t, and each delta t is just f times the previous delta x. In the game, because of the way we're plugging this into later World 4 code, we solve for the sum of all delta x from delta x0 to delta x infinity. If you wanted to think mainly about time instead, you could solve for the sum of all the delta t's. Because we just multiply v times f every step, this is a simple geometric series. It converges as long as v times f is less than 1. If the platform were moving fast enough, it could carry the player faster and faster with each step, so that an infinite amount of distance is traversed, which would make it pretty hard to play the game. Fortunately, as long as v times f is less than 1, there's a closed form solution for this equation, and this is it. To get the sum total of an infinite number of time steps, we just divide delta x0 by 1 minus v times f.
这公式写出来挺乱，但其实真正的最后的答案 form 还是挺简洁的，就是一个这个 convergent geometric series， 它是小于1的。这个可能算是高中知识。Using markers to trigger events in the backward time system of World 1啊，这地方还挺难，怎么一个顺序来玩呢？啊，差不多，这没看过。Markers 啊 ，World 1 是
Once I had decided on the basic way this world
啊，
works,
这个东西，既然看到了，说一下，懂我什么意思吗？对，这个是能直接跳的，我就要把这东西说清楚。
Once I had decided on the basic way this world works, that the player would go forward in time, while all the gameplay objects would go backward in time of their own accord. There remained a big question about how to make this actually happen in the code. Since the gameplay engine of Braid is all about recording the history of objects and playing them back later on, the most obvious idea is to use that same code just to make everything go backwards. During development time, you would set up a level with monsters and whatever else, and you just let it play with time going forward and record the history of that, just like we do for normal rewinding. Then, when someone is actually playing the game, you load that recorded history and play it backward, and the player is just exempted from that rewind and simulates forward normally. This was the first thing I thought of, and immediately I felt it just wouldn't be very good, because you'd never be able to affect any of the objects because those objects could only do what was pre-recorded. If you couldn't affect anything, it seems the game design would become monotonous, and all the levels would just be about bouncing off invulnerable monsters, or whatever. I wanted at least some reverse causality, for example, jump on a dead monster to make it alive. This brings a little bit of magic into the dynamics of that world, and allows there to be cause and effect for something besides the player. Now, there might be ways to do this by pre-recording everything. For example, you could record multiple histories and branch between them based on the player's actions. This would use a much larger amount of memory. It would be very messy and hard to program, and it would constrain possible player actions only to the places that were pre-computed during development time. This constraint might prevent you from designing what you really want to design. The much more appealing alternative was to make a way for monsters and gameplay objects to somehow simulate themselves backward from moment to moment in the same way that they go forward. Monsters would undie and unfall. Figuring out when monsters should undie is not too hard. Clearly, it's when the player is bouncing off them. But when should they unfall, and how does the game know when and where they started falling so they can simulate back to that point? There are a few different ways to do all this. The solution I implemented does involve simulating the level forward at development time, like the pre-recording idea would have. But instead of recording the history of all the objects, I added some special code that creates invisible markers wherever major events happen. For example, when a monster hits a surface and bounces off, we create a marker and also record the velocity at which the monster had been traveling when it hit the floor. We save those markers with the rest of the level, and now when the monsters are walking backwards, there are indicators of where they should unbounce from their fall and then unfall upward. And at some point up in space near the ledge is a marker that says, if a falling monster passes through this space, it should land here. The idea is that during gameplay, we just simulate monsters backwards. So if a monster is alive, he walks backward, and if he hits a marker, we make something special happen. Here are the bounce markers on this level. Each marker says, hey monster, if you get here, launch yourself upward with some particular velocity. The negative velocity of the one we recorded when playing time forward. As long as the monster did not fall far enough to reach terminal velocity, then this should launch the monster back up to exactly the place where it fell off the platform. In reality, because of small inaccuracies in the way the game is simulated, these markers did not reproduce the motion perfectly backward, and I had to tweak the results by hand at least a little bit.
Marker
There's another
tweaks.
kind of marker up here on the cannon that says if a monster ends up inside this cannon, make it disappear. Also make the cannon fuse start unburning. We also need to start playing the sound effect for the cannon shot from the end and going backwards so that it finishes just when the cannon would fire. This is accomplished with more markers. When playing the level forward in developer mode, when sound effects finish playing, we put markers wherever the current monster is, so that during gameplay, when time is going backwards, we know when to start the sound effect.
Yes.
In other words, the cannons are not firing based on time, but based on the monster's position. This jump to revive situation becomes a little weird, because what happens when you aren't jumping, but you're just standing there, and the monster comes up to meet your
对了
feet?
对了，这个其实
If
挺
we're
奇
keeping
怪
with
的。
a strict interpretation of the rules of the game, maybe what should happen is that the monster just stays dead and keeps falling upward past you, because you couldn't have killed the monster if you weren't jumping.
对的，
So, to unkill a monster, if we're being strict, you would have to jump into the air right above
jump
the
in
dead
there， 对，
monster's
这样
head
就能跳上去
at just the right time, such that it would be plausible you had bounced off it. But if the game were this picky, this might make levels extremely hard, and it might be really annoying to play.
嗯，
Hitting the monsters, unfalling quickly up the screen, would require difficult timing because the monster is moving very
这个其
quickly
实
and
不
you
简单，
can't
你需要
stop
rewind，
coming
对
because you need to hit it near the bottom of the screen where
大
you're
概知道
standing.
节奏才行。
And if the player isn't even sure that this is the right way
这
to
个算
solve the
改写历
puzzle,
史
the difficulty in execution adds ambiguity. Is this the wrong answer, or am I just failing to do it properly?
改写过
It's
去
not something you want players to be confused about in a puzzle game. So, I made the judgment call that just standing on a dead monster would revive it, but pop you into the air in a jump.
into a jump。
So in reverse, it looks somewhat like jumping on a monster to kill it. It's just that the positioning is slightly awkward.
对的，
If I were designing the game again with the experience I have now, I might try harder to remove this standing bounce and make it workable that we require the player to jump. For example, I might redesign the level so that you can see further down below the
有道理。
playable area to see the dead monster
对，这样
climb
就能
up,
判断了。
which itself would be suggestive that you should
现
jump
在
on.
很难判断。
And I'd try to somehow hint the jump in other ways. But doing a good job would require changes elsewhere in the game. For example, if we let you see very far below the play area so that you could time the jump, it would feel very out of place compared to the rest of the game, where the floor is always near the bottom of the screen. There is at least one level where portions of the play area are pretty high up the screen, the pit, but that's because we want to make room for the pit itself. Not much play happens on the higher part of the level, which is off to the sides. And the rest of the game still sets the expectation that
The
the ground
pit.
is low down. One way to make this more natural would be to make another level earlier in the game that also has a high floor, and then have this level be a reprise of that one. Reprises are something we do a lot in the game already, but it's not easy to add more levels into a game that has a fixed number of puzzle pieces per world. Which other puzzle piece do I remove to make room for this one? And how do we make that level interesting? In order for it to feel good, the puzzle would have to have something to do with the ground being high up. But the gameplay excuse for this can't be reverse time because that doesn't happen until later in the game. So what could it be? It's just not easy to be a picky game designer.
之前那个 Doctor 那段还是很简单简洁的，一旦到了这个 John 的个人独白专场了，那种感觉又回来了，那种感觉真的又回来了，这肯定看过了。
This level, end of city. You love this five.
那个设计其实改写过去，本来这怪是碰到了火刺然后挂掉的，现在你踩在它上面，改写了过去。
or arbitrary, and so that you don't feel like you were deceived in some cheap way by a complex level.
是你把它踩掉的 marker tweaks， 真没看过，这什么地方 marker tweaks？ 而且还有2个，很可能就是这儿啊，果然是这儿。那其实可以在这儿把它看掉的。叫 The markers for World 1 didn't quite work correctly。哦，是吗？一口气看掉了这2个。
When confronted with the fact that reversal didn't work perfectly, so that monsters flung into the air by these markers did not reach exactly the place they came from when recording the markers, the ideal thing to do would have been to keep working on the simulation code until the reversal worked perfectly. But when you're overwhelmed by the number of things to do to finish a game, and the simulation code is already pretty complicated because it has to support all kinds of different rules from all the different worlds, it can seem much more appealing just to do the quick fix.
Quick
And
fix。
tactically, this is often the right solution in terms of actually finishing the game. Especially back when Braid was made, lots of independent games would fail because the authors just got overwhelmed by how much work there was to do, so the games never got finished. I was very, very mindful of this and wanted to finish the game at all costs. The downside of a quick fix is that the imperfect reversal could be a symptom of some much deeper problem that is affecting other parts of the game in a negative way. And by doing a quick fix, rather than investigating and fixing the deeper problem, we could be causing big bugs elsewhere. Maybe rare bugs that we would not catch in testing, but that would cause bad experiences for a significant number of players. Many other games have had exactly this kind of problem. On the other hand, the imperfect reproduction of the markers could be a simple issue that affects only the World 1 levels, like a simple dependency on the order in which we
因为只有
update
这张有
velocity and position. I chose not to open that potential rat's nest and just do the easy hand tweaking and work towards shipping the game. And maybe this was the right choice because the game did get finished.
Did get finished。你是首先是完成这部作品呢，还是说精益求精？这种又是不同的判断。你无论选哪一边都有好处，都有坏处。
So
6分29。
you were asking,
I didn't
what
ask.
about it didn't reverse correctly?
And how did you tweak it by hand?
Who are
How did
you,
tweak it by
mate?
hand? Let's do the latter part.
这应该没听
So
过
the。how I tweaked it was very unscientifically because, there was a position for the marker
采访
and there were velocity numbers on it of what it was that the monster came in at for bounce markers, for example, which were the ones that were usually wrong. Or also, there's a stop falling and land back on the ledge marker as well that had the same problem. And I mean, honestly, I would just move it a little bit by hand till it came out right, and I would type in different velocity numbers slightly. So that was not very scientific. But it was still helpful to have this system because it got me very close to the answer, and then I just had to tweak those things. So why does it happen? So one of the basic things that happens, when you're doing collision in a game, every frame, you want to make sure that the player is always in a valid area, right? And so the simulation process is like, okay, like if you just have something moving ballistically, it's like, okay, I'm just going to add velocity and acceleration to this thing, and it's going to end up somewhere. And then I check to see if it hit anything in the small time step that we just did, right? Which at large time steps, that could be very messy and you could get very bad results because, it depends on how carefully you determine what was the first thing it collided with, right? You could imagine if your time step is really slow or your velocity is really fast and there are two things in the path and you happen to only look at them in the order of however objects are stored in the world, you might get the other one, right? The second one, when you really want to get the first one. And so systems tend to be very careful about detecting the time of first collision. So if you use a licensed SDK like Havoc or something, it's going to do that, right? I was just writing my own physics, and I don't think this game would run very well with something like Havoc or anything. So it's a very simple thing about like, oh, I noticed we detected a wall. Let me snap you back outside the surface in some way, right? And so when we're talking about impacting a surface, then the place where the monster ended up is actually inside the floor, but then we pop it up and then it walks, and so the monster walking back is going to be above the floor. And so like the velocity numbers that we get are correct for inside the floor. They're not correct for on the surface of the floor, right? And then also the monster might move laterally a little bit when we pop it back. Sometimes there's just simple bugs like the way that you're updating your velocity and acceleration may not be very close to time direction invariant, actually. Like the structure of your code is it's t sub n. So I'm gonna add velocity, add acceleration to my velocity or whatever. And you maybe do something a little more sophisticated. Like in Braid, I think I use the midpoint method, which is a way
midpoint
of
method。
getting a more frame rate independent result with very little computation. So you do that, but the structure of it is like beginning of frame, velocity, acceleration, and then you probably do the 1/2 AT squared to apply it to the current thing, but the point being that acceleration is added into the velocity for the next frame. And then if you run time backwards, you kind of want to run the opposite. You want to run all those calculations in reverse exactly to get the right thing, but it won't be in reverse exactly because it's start of frame,
Oh, I see.
do stuff, right? The structure
Yeah.
of you would actually have to write a different loop, I think, to make it go backward, which I could have done if I had had the clarity of mind to do that, but I didn't.
Why do you want to redesign to have Tim not pop off if he's going on a monster? So the monster's going backwards, it's going to come alive, and he said it just pops you up, right? But you want to get rid of that? So the player then has to jump themselves?
Oh, yeah. I'm not saying I want to get rid of it because I don't have a better answer of what to do practically. Like the stuff I was suggesting at the end is more like the thought process of what I would do if I truly felt it was important to do that, right? But the decision that I made at the time was that it was actually better just to leave it the way that I shipped it. And, you know, there were some other factors that played into this. So one of them has to do with all the awkwardness that I was talking about how it would be to like sell it better, that you had to jump on the monster. But another one is because before this I had designed the final level of the game, which also, you know, has time going backwards, and there's a lot more stuff in that that isn't exactly right. So for example, you jump off pretty high ledges like down, and when you reverse, you know, it flips your bitmap and you're like jumping up, but you're jumping up much higher than you would be able to actually, right? And to avoid that, like if I were being very, very strict about that, I would have to have a very constrained level design process where like you could never fall more than a couple player heights or however far you can jump, right? And so I didn't want that limitation. It was very hard to design that level to begin with, right? And so I already knew that I was not trying to make it be like exactly like you could imagine. It's like, okay, this is reverse time, so anything that happens forward when you reverse it has to look exactly like perfect gameplay that you already would have seen in the rest of the game, right? And that just wasn't realistic for good gameplay as far as I could tell. And so I had already decided, hey, we're going to be a little bit soft about it. Like there's going to be a weirdness about things going in both directions of time, and the way they affect each other just creates a little bit of extra strangeness, right? And I think that actually makes sense in a lot of ways, even if you think about it deeply.
啊，果然直接回到这儿了。怎么走来着？看到里面都赛계속。Fuck you！ 顺序该大一些了。从这儿 ，Getting bitmaps from tools into the game， 看过的。了。
Is your just quick
procedural thing。
Just
and
by which
串的。 刚刚那什么图来着？
all these part example without any kind of
啊，好，这
what I enable format, right? Possibly chops it into smaller pieces, both because there was a maximum texture size in those
Texture
days,
size.
right? Which is variable based on platform, but we could be like, well, we don't want any pieces to be bigger than 256 pixels wide or something.
Right. Chopping up bitmaps and packing them tightly. 这是哪儿？啊，这 Brian Moriarty shit my boots， 在这儿，不是这都算 technical hurdles。
There are two things you want to do during hardware time. Which is I give you XD was 720. I saw the NREC tech and it's anything on the same.
Oh,
kind of
讲这
very
个
different things.
chopping， 这里的话先看这个吧。刚说的 Braid was made as a 2D platformer to limit technical risk。这没看过。上古时期型。The first thing you need to do is to make it 2D to avoid some problems. That's the last sentence.
Some way, was played by little. So, firstly,
eliminate technical
challenge
challenge
and design challenge
by being 2D. Right. 这其实很好的建议。Challenges of loading and remembering bitmaps on the game's original launch platform Xbox Live Arcade on the Xbox 360 什么 the hurdle 是吧？啊，就这种 technical hurdle。
On the Xbox 360, on the GPU than it should by a lot, because I'm trying to fit everything into memory the whole time. So that was fun.
对，这个其实也算是 programming 的领域。Some extra programming that maybe shouldn't be there. 啊，这个
Here is a
这个也算
far away.
programming
The pair of a purist about these weird hats.
purist。
But there's still something enticing about the symmetry of you and your shadow entering a tunnel from opposite sides, having the rabbit chase you in opposite directions. I wonder if, by working on this further, I could come up with an even better version of this puzzle that retains that symmetry.
对称的艺术中，你确定这不是强迫症的艺术？我觉得特别喜欢对称，看不惯不对称的都是有点强迫症。Including myself. Making the clouds carry the player when time is mapped to play space. 马上就要结束了，就这个，这肯定看过。这个不是那 Doctor。
These cloud trails back toward you.
A callback.
These things, and we can just barely make it onto the next platform.
I mean,
Leap of
really,
faith
that's the
and-
kind of leap of faith in the game.
Right.
Honestly, right?
Right.
Yeah.
So that's nice.
That's pretty nice. OK， 没了是吧？啊，去顶上有2个地方错了。那这一期很快就结束了，我不想搞别的东西，可以练一下一些操蛋关卡吧。Overtaken， 这果然挺短的。怎么还是 BGM？Fuck！ 而且不是，他怎么走的这么快了？不对呀！啊，这一关的小怪移动速度是不正常的，是吧？Damn fuck！ 啊，这个是能踩掉的。啊，对，是能踩掉。不是，好快啊！我操，看，瞬间就过来了。耶！我们死了，简单一开始了。而且那片居然是绿光的。那往这儿走呢？可以吧？哎，别把他踩死！我操，瞬移了！我 ，That's damn hard。不是，这好难啊！这个操作很不合理啊！我操！你也不能让他死掉。Nice， 快！这个操作，我觉得只能通过试啊，你没有办法通过上去了，没上去，damn。早すぎ。なん呀，这关什么关来着 ？Overtaken 是吗？哦，你靠，整个这怪的跟移动速度都比我快。Programming braids even more usual particle systems. Programming braids unusual particle systems， 这个是 usual 是吧？啊 ，even more unusual. Elevator action， 这没看过吗？啊，这关既然打到了，这里不用练，练一下吧，2个是吧？
Braid's visuals are very dependent on particles. We use lots and lots of particles to create interesting looking motion in both the foreground and background. But all these particles need to rewind perfectly. That was one of the basic principles I adopted early on. The naive way to rewind particles would be just to store in the rewind buffer the position, speed, color, and so forth of every single particle for every single frame. The naive way to rewind particles would be just to store in the rewind buffer the position, speed, current color, and so forth of every single particle for every single frame, just like we do for any other gameplay object. And then we just restore those properties when you go backward in time. But this would use a huge amount of memory. Typically, there are only a handful of gameplay objects in a level, but even in the original game, there were thousands or tens of thousands of particles. Storing all that data would eat almost all the memory available for rewind, which would seriously curtail gameplay. Because each frame would take much more memory, we would store many fewer frames, so maybe you'd only be able to rewind for a few seconds instead of the 15 to 45 minutes that you could rewind in the original game. To get around this, particles in Braid work differently than they do in any other game I'm aware of. In pretty much every video game, particles are implemented as follows. You have some function that creates particles each frame, picking random properties like size, color, speed, and so on. Then you have another function that simulates all currently existing particles forward for a short period of time, applying gravity, drag from the air, changing the color of the particle over time, deciding whether the particle has completed its lifespan and should disappear. This function then gets called every frame, and each time it computes the new state of the particle, this just overwrites the old state. Once you've rendered the frame, there's no reason to remember that old state anymore. But under this scheme, particles simply can't go backward, because this simulator function isn't bidirectional. Basic rules of physics, like air friction, destroy information.
Air friction.
For example, once you've reached terminal velocity, it is not possible to deduce what speed you were going one step in the past. And once a particle has disappeared, you wouldn't know how to recreate it in its final state because all that information is just gone. But the classic particle implementation provides some hints for what we can do to fix this problem. Classically, when the particle is created, we get its random size, color, and so forth from a random number generator, and we were careful to seed that generator with a good value to ensure the output is fairly random looking. When you seed a deterministic random number generator, this determines the sequence of numbers that you will get afterward. That's what deterministic means. In normal situations, you just seed a generator one time. But if we take the unusual step of seeding the generator for each particle, based on some numeric identity of that particle, we could get reproducible results out of that spawner function no matter when and how often we call it. Seeding for each particle puts more demands on the random number generator. Low-quality generators can easily look less random if you seed them too often. And I did have this problem initially. Even higher quality generators can produce artifacted results if you seed with low integers, for example. But there are some simple strategies to just mix the numbers up a little to generate a higher seed value that is still deterministic. In order to make this per particle seeding work, we need an easy way to compute each particle's ID. Since each frame, one thing we do know is what time it is. We build the system so that the time allows us to uniquely identify a particle. For this to work, we take another unusual step, designing the emitters so that each one holds a fixed number of particles only. For example, if an emitter emits 1 particle per second and holds 10 particles, then each particle has a lifespan of 10 seconds. If the current game time is 35 seconds, then the 10 particles in the buffer will be particles number 26, 27, 28, and so on up to 35. These indices correspond to the spawn time of each particle, and thus they uniquely identify each particle. Now if we render a frame at 36 seconds, we will have particle 27, 28, 29, and so on up to 36. And these will all be the same ones as the previous list, except we dropped 26 off the front and added 36 to the back. This strange setup allows us to pick any number whatsoever for the current time. And then we know what particle numbers exist at that time, which means we know how to seed the generator, which means we know what all the particles look like exactly, even if we decide that this frame should be time equals 1 million seconds, and next frame should be time equals minus 1 billion seconds. So all particles have fixed lifetimes, but if we want to give them the appearance of variable lifetimes, we just fade them out faster or slower and just don't draw particles that have faded out all the way. But these particles do still functionally exist. So far, we've just been discussing the creation of the particles. But after they're created, we need to run that simulation function to evolve them over time. How do we do that? In principle, we could just do the classical particle thing and run small simulation time steps for each particle until we get them to the current time. But because we're recreating the particles each frame and our particle buffer holds particles of a range of ages, and some of them might be very old, we have to watch out because each frame we might be simulating way too many time steps and our game could run very slow. You might start thinking, hey, when you're going forward in time normally, you just save the data from the previous frame and you only need to run one time step. You only need to do this complicated slow computation when going backward in time. Lots of computer science papers encourage this kind of strategy, but it's a bad way to think for interactive programs if you have any alternative. We want rewinding to be natural as walking. In fact, walking is rewinding in World 4. Either we can maintain a solid frame rate when rewinding, or we can't. If we can, then whatever we're doing for rewinding works for going forward too. If we can't maintain that solid frame rate when rewinding, well, that seriously damages the solid feelingness of the game, and we should work hard to change this. So I didn't want to consider some incremental system that has these kinds of problems. I wanted a flat system that would run at the same frame rate always. You might think about reducing the CPU load from the lazy approach by combining many simulation time steps into one so that you're just simulating one step representing a larger duration of time. Or you might try running many small steps but with a simplified function that's cheaper to run. But these approaches would not result in perfect visual reproduction of the particles, and in World 4 this could even result in large objectionable discontinuities while walking, since you can walk left from a frame that you just simulated a moment ago to a frame where you were 5 minutes ago, and these need to line up seamlessly. In general, video game physics gives you different results when you simulate things for bigger or smaller time steps, and games that are carefully crafted might employ a variety of techniques to deal with this problem. So if your particles are doing normal physics, you can't cut corners, you just have to do a lot of computation. However, the particles in Braid don't affect gameplay in any way, they're just cosmetic. So we really have a lot of freedom about what the particle simulation function is. Rather than simulating exact physics that could cause problems for us, like the aforementioned air resistance, we can do simpler things that can be expressed in closed form. For example, a parameter like, this particle slows down by 1 meter per second every second. This seems kind of physicsy, but it's frame rate independent, so you can take arbitrarily big time steps. This specific idea of constant deceleration has disadvantages, since if you let the particle live long enough, it will slow down, stop, and reverse direction, which is probably not what you want. But just don't let it live that long, or reduce the slowdown rate. Closed form means we can express the entire evolution of the particle in one short mathematical function, regardless of the amount of time we're simulating it for, and we always get the exact answer. Combined with the deterministically seeded spawning, this gives us the ability to reproduce the state of any particle at any time without storing any per particle data at all. This is how most of the particles work in Braid. Each particle is recreated from scratch and simulated to the current time every single frame, whether we are going forward or backward. The particles don't really exist at all between frames, as we don't keep their data at all.
这段相当的技术性，相当的 technical unusual particle systems 啊。这段如果你没有一点相关的这个基础知识储备的话，应该是会跟我一样听得云里雾里。
I said that most particles in Braid are handled in a fully deterministic way, where they're regenerated every frame, and apart from that, mostly don't exist. But when I got to World 6, I needed something else. I wanted particles that helped clearly illustrate the slowdown effect of the ring. But the ring is under your control. You can take and drop it any time. So if it slows down the particles, there's no way to represent those particles' positions across time in closed form, which means we'd need some kind of storage for them. On the other hand, if the ring doesn't slow down the particles, that makes the game weaker. So I wanted to come up with a solution for this. So I bit the bullet and stored the positions for some particles only. For World 6, I introduced a new kind of particle emitter called the Rainmaker, which drops the snowflakes that make the most prominent motion. Yes, The Rainmaker drops snow. It used to be rain, but we often don't rename our entities when the cosmetics of the game change. In the Anniversary Edition, we sometimes use Rainmakers to generate additional animated clouds. Because these clouds have a lot of motion, we want them to be slowed by the ring as well. The Rainmaker has a loop that saves out the positions of these particles in a tightly packed, efficient manner, and it also saves out the position of the ring over time, so that we don't have to save out the particle positions every frame. We just simulate the particles forward for some limited number of ring positions, so that we don't spend too much CPU doing this. After a certain amount of time has passed, we record new Rainmaker information with new positions for every particle. If you're familiar with video encoding, it's like storing iframes, which record a full frame of video, and then p frames, which are just smaller changes from the previous frame. To reconstruct the current state, you just go to the closest previous iframe and then simulate a small number of p frames. Besides packing the snowflakes efficiently, we just make sure there aren't too many to begin with. We just want to use them to visualize slowdown, so they're distributed through the space enough that we get a moderate density of them everywhere, but we don't rely on them for the most compelling visuals. Behind the snowflakes, we still have lots and lots of normal braid particles whose positions are not recorded, so they can't be slowed down. But the art style of World 6 is tuned so that these particles are subtler than they may be in other worlds, and they move more slowly, so you don't really notice that they're not affected by the ring. The snowflakes tend to be much louder in the player's attention. Sometimes we do add particles that move a bit faster, but these tend to be placed far enough from any potential ring drop points that the lack of slowdown is not too noticeable. By doing all this, we are able to achieve our goal. Note that this was a hybrid of technical solution with purposeful art direction. A lot of the best problem solving in games happens as a fusion of multiple disciplines. It's a good idea to always view your problems in a holistic way in order to help see how to bring the different disciplines to bear.
OK， 这样的话，这个 programming 就结束了，大半期就搞定了。下一期来打这个 playthrough， 把拼图拼完，然后有个1-2关感觉可以练习一下。看不出来，这个应该放这儿。这儿是吧？还有最后3片了，还有3大区，一共就有3片了啊。playthrough 很可能1片都没有了。从这儿进去，一路要进去。Here you can play the game in a normal way from the beginning with some commentary. It's not all commentary that exists, and that would be too messy. It's a set hand selected to be nice in with linear play. 哎，这样的话你根本都看不到哪些 commentary 你已经看过，哪些没看过了，有这么多。啊，这个只能凭记忆力了。It's going to be pain in the ass. Playthrough， 有个2-3关，我觉得可以稍微再回一下。啊？不是为什么都断掉了？这什么情况？对啊，就是这个存档，这为什么都断掉了？这个是 bug 吗？那第一个来不及了，要去熬第2个，就慢了，等的稍微久了点，可以了。这个练一下，这关相当费时间，关键那个地方不能慢。乍一看好像正常走流程就是一关流程关，但那个地方是不能慢，单慢了就 over 了。一定要刚好踩着那怪上去，妈知道就知道了，不知道的话就会慢很多。走啊！ 完了，这可能慢了。啊，这慢了，这地方一旦慢了就死了。对，因为他会走回来，这样的话只能往回走。这里是不能慢的，基本上这只是要踩得上去的，对，只要能踩上去就行。哎，这边稍微调的不难，完了之后是等这只，对，等这只过来之后卡进去，这样就可以了。后面就给口，对，后面就没什么可以讲了。这个地方是一个比较操蛋的点。还有哪关了呢？第一世界玩大开始来看一下，想一想，这个是那个绿光的关是吧？啊，雷尔都可以练一下。啊，对对对，听个里面都在了。这 face， 这个是那个 The ground beneath her feet。啊，还有这个。啊，这样就 GG 了。这东西倒也挺烦的。一旦挂的话，就要立刻回来，回来再切进来这里。哦，对，你可以先打这儿的，收进来。啊，这可能也完蛋了，没准已经不行了。只要把一开始那个线卡过去就可以了。很可能不行是吧？啊，卡住了！我操，认真了。是一点都不能用 rewind 还是怎么样？あ、ちょっとの rewind 应该いけるの。哦，这居然是卡住了！マジか！那这个兔子收有2万呢，或者说你可以先夹死。那这个地方肯定也不能用了。まあ一瞬のあれは大丈夫了，这都应该没事儿。到这个位置，我相信应该已经可以了。Fuck sake！可以了，可以了。妈，别的一些动作游戏多多少少如果玩过一些都还行，讲道理。否则这个 speed run 你要非常痛恨，觉得它非常恶心，我觉得我也不是不能理解。そもそもこういうゲームじゃないので，对吧？讲道理，这游戏你真觉得它跟 speed run 有什么关系吗？就你强行设计了这么东西。往这儿走了。哎呀！还是需要3发，2发搞不定。 也不太会玩。这个好烦呐、这关。还是要保证基本上2发能带走。跑这儿来。挂了。这样2次带走了，还行。2套。check。めんどくさいなこれ。这样就来不及了，因为那个地方卡了一下。这里还能浪费时间。这次是来得及，后面就不用看了，还能再快一点。啊，果然可以。哦，这个地方爬上来了，摸不到就掉下去就好玩了啊！但不过这样应该可以用那个 rewind。OK， 这个是这个，把这个个别关再看一下。这一关是那个什么，当当当当当当，米蛋。这个的话 jump man 啊，这不用了，就少了一个这个 exit the current world， 这功能一旦没有了，确实不习惯。这不用练，这关我是有。不影响啊！这个很烦，这关非常烦。不对呀，不是这么玩的啊！其实根本就不用想那么多，是吧？这关的那个思路，我觉得是有问题的。我才不理你呢！对，到这儿再说吗？到这儿再说吗？听到叮的一声，瞬间，对，瞬间回来去。拿到之后再啊，这个不能啊，原来是中间不能松的，可以。进阶哦，马起来也没了。跳，这里是能跳过去。まあさすがにこれはここは俺やらないから。耶，ダメに了。不能松，到这儿就完了。这样就可以了，中间 X 不要松，这样可以一键过来，因为那个花太麻烦了。就这个地方的话，其实如果你从刚刚这里一路过来的话，对，只要这样就行了。但这个难度会稍微大一点点，虽然快一些。 OK， 这来得及，来得及，来得及。这样你不用往上面绕一圈。OK。啊，これもだるいな。Fickle companion。把这两关了嘛，这个其实没什么太难。就不要搞得太麻烦就行。Fuck you! What? 唉。拿不到这钥匙为什么？啊，你不能往左走是吧？就这样，一屁股坐死他。这种可以了吧？踩掉之后开了门之类的，对这一套应该就没问题了。这样可以，再来一次。そこまで苦手じゃないけど，但你可以理解一票玩家对这游戏的痛恨。这个应该是我觉得开发者 John 的一个误判。这点上他应该是没想到的，还是有些所谓的 achievement geek 的。就虽然手可能不算太巧，但就想把这个成就完成，就是有这样的玩家。哇，大多数所谓的这个 achievement hunter， 你多多少少还是有些这个无敌麦的。你不管是这个黑科技也好，还是操作也好，否则怎么刷东西呢？有些游戏的这个成就都不是正常能打的，它是有一些鬼畜东西在里面。打多了之后，你的操作自然能上来。但也是有这样的玩家，在这个游戏的解密游戏是吧？本来是动脑子的，不是靠手的，手很残的，照理说也能玩。然后后面跟你莫名其妙搞了个 speed run 的东西。这个东西一旦出来，就明显告诉你，如果手残，不好意思，那你就是 you are going to suffer，get ready for that， 就这么意思。而且关键它这个设定，哎，这个一遍应该能过去了，但实战不一定能。啊，可以的，可以的，然后再往回来就好。It's okay, no, it's okay. 不要松啊！不要松！不要松！不要松！不要松！不要松！不要松！不要松！不要松！不要松！不要松！不要松！可以。いやお前何やってるんだろう。是呢。阿火他嘞，回来，跳上来，边缘起跳，再来扫。最大的问题在于它这个45分钟是吧？且这种打法的游戏，如果你没有什么太多经验的话，就经常会出现到最后你会紧张的。这个虽然看起来是人之常情的事情，但你要知道不是。お前、俺の木を返せ、ガキ。俺の木を返せ。なんでそういうこともある？マジか。啊，これやっぱや。这种概率是有了。不老老师把我的钥匙交出来，我操！死罪可免，活罪难赦。啊，你要这样就很麻烦了。他这样的话，刚好把钥匙掉到这儿。对，我就需要。对啊，这就不行了呀，这反而更慢了。哎，这要研究一下。就说的什么情况呢？就是打到大后期，中前期呢不能说很快，但基本没什么问题。然后在一关连续浪费了3-5分钟之类的，就这个意思。这个游戏体验完なかなかだるいです。啊，那这样只能到这儿了，是吧？这个打法可能也只能这么搞了，是吧？ 不算是这个具体去剖析，但只能这么搞。如果要是刚好能留下来能带到，那就带到了；带不到，看来只能等了。属于具体问题具体分析了。寿司拿团没拿。哦，我懂了，你没有从这里过去，这个最大的问题哦。那可以稍微，这个可以稍微再改一下。对，一开始就要慢了，是吧？对，一开始如果你从这儿走就要慢了，而且你东跳西跳的话，这也是一个问题。所以其实差不多了，这样看能不能保证拿到钥匙。好像也不见得拿得到，也差不太多，那就没什么意思了。那就没什么意思。那还不如前面稍微快一点，蹬步直接上去。到这儿都没什么区别，很快的。就这样吧，就这样。5跟6等有时间可以再打。下一期先从这个 playthrough 开始。这个绝对是开发者的一个误判，他觉得成就不就成就了，你真的要愿意刷，你就应该没有怨言。他觉得你只要刷了就不应该有怨言，你只要有怨言你就不应该刷。结果没想到还真有打了好几次，结果都是50分钟左右。这我倒觉得确实嘛，5代麦都蒙打了呢。他这个40分钟其实上一次打下来我就感觉还挺宽的，基本上还是挺宽的。当然我是 commentary 看了这么长时间了，很多关你算练过了。如果你直接没有练过无脑打的话嘛，打几次配合手残很可能还真的有这样那样的问题。关键他这个操作跟他这种设计，45分钟 speed run 的设计跟操作是有很大的挂钩的。而这种游戏它上来就给你一种感觉，第一它是艺术啊，第二它是谜题解谜游戏，那么就不应该对操作有什么限制，这点是有点欺骗性。然后你发现你要想获得所有成就，把这个游戏白金掉完美掉，你就发现你居然还需要一个你乍以为不需要的东西，然后你就要开始受苦受难。打了40分钟，然后到最后你很紧张，心跳加速，失误了，47分钟，操天啊，还得再来一次，这种感受当然操蛋，所以也不是不能理解吧。